Okay, so we have this, and we're going to rewrite this this formula as that. Okay, and just to quickly review, all right, we are trying to find the area under this curve, and using Fermat's method, we would measure the area of these squares, which were measured by these distances from the origin, right? Which formed a geometric progression, giving us finally this. Okay. So what we're next going to do is we're going to factor out. A 1 minus r out of this. So we got this, right? And then when the 1 minus r's cancel out, we have this deal. Now, this is the kind of the tricky thing about Fermat's approach, because this isn't precisely the area of the curve, it's just the area of these rectangles added together. But it kind of depends on r. If r is closer to 1, then these rectangles become more and more precise the closer r is to 1. And so Fermat sort of envisioned the concept of r approaching 1. And this is before the limits were used or probably even existed. Okay, so it was kind of an intuitive insight on Fermat's part to do this. When r approaches 1, or if we suppose that r equals 1, we get this. And and that's just the same as this, having like n plus 1 of these, which finally gives us this. And this is the area under the curve. It should look familiar. It is the the equation for integration for an area under the curve given at a point of A. Okay. Now, one snag, it does not work for the area of the curve y equals x minus 1, because of course, by following this formula, given a certain a, we would get this, which of course turns into this. And this is a big no-no. This is undefined. So the problem remains.